本视频由海外兔联合制作。
Should I just introduce myself?
Yes, please.
First? Okay, so hello everyone. My name is Shilong, and you can call me David. And I'm currently a student at University of Washington studying applied math. I'm really interested in software development. In my undergraduate study, I study classes like Java, Intro to Java, data structure and algorithm, and etc. And I'm looking for a software development job. Yeah.
Okay, so I will still give you a question about your resume. So could you give me a brief introduction about your project of the video stream?
Okay. Yeah. Okay. Let me to open that up real quick. Okay. So you want me to introduce the stream video intelligence platform?
Yes. So why did you choose this project, and which part impressed you most?
Okay, so this project is on Google Cloud, and the reason why I choose this project because I think there's a really practical reason because by using such stream video platform, we can actually analyze our video feeds in real time, which means we can make business decisions in a really fast response. And I think this is a kind of cool idea, and this also let me get familiar with Google Cloud services like Dataflow, BigQuery, and Google Video Intelligence API. So I decided to do this project. And during the project, I think one thing impressed me the most is how this thing is structured. So at first I started to build this analytics platform on Google Cloud, and first we had to feed the videos, and the video is actually saved in cloud storage. And in the cloud storage, the Google Cloud Storage API actually uploads the videos and split in parts and analyze the video segment in the BigQuery. And by deploying this cloud storage, I can actually process this video later by using the video clips stored in cloud storage. And I also one thing I did in this project, I created pop-up notifications that deliver the videos and the information the business is really looking for from the platform to the organizations to let them to make the business decisions. So after feeding the videos, you can just after feeding the stream videos, monitoring what's happening in the real world in real time, you can actually just do analyze the video clip just instantly and just process what's important about the video clips by using the Video Intelligence API. Yeah, that's the thing impressed me the most, I think.
Cool, that's great. So I'm going to give you a algorithm problem. Okay, are you ready?
Yeah, I'm ready.
Okay. So can you see the problem?
Yeah.
Okay. The name of this problem is called Chinese horse. Okay. So starting. So I'm going to repeat the description about this problem. So imagine that you are a Chinese horse chess, and you are starting from x0 and y0, and you are jump to the target x1 and y1, and you will jump like a horse in Chinese chess. And more specifically, the horse can jump right and top, so it will move 1-2 or it will move 2-1. And I'm asking you to find out how many ways of jumps it can get to the target.
Okay.
So here is an example for you. So you are starting from 1-1 and you are jump to 4-4. and you can see that you have two ways to do that. Okay. So regarding the description, do you have any questions?
So the starting point is 0, 0.
Yeah.
But like in the okay. The starting point is x0 and y0, and it can be like, so in this example, x0 is 1, y0 is 1. And does it guarantee to have an answer?
No.
So not guarantee. Okay. So how many ways to get to the target? So
yeah, that's a good question. It's not guaranteed.
Okay.
Okay, but so, you can assume that it's guaranteed, and you can modify your solution later, or you can treat the edge cases at the very beginning of your solution.
Okay. Yeah, maybe just return -1 if the answer is not found.
If no solution, you can return 0. That makes more sense.
Oh yeah, that makes sense. Okay. And can I ask what's the range of the input for the starting points and target points? Are they all integer indexes?
Let me think. How about that? I won't give you the range first, and you will tell me what is the what is the range that your solution can solve.
Okay.
Okay, let's do this way.
Yeah. So yeah, I do understand the question's meaning. So so in your can I write on this?
Yeah, you can start if you are ready.
Okay. So yeah, I'm still thinking about the problem because in your example, like there are two ways to get from 1, 1 to 4, 4.
Mm-hmm.
And the way it goes has been specified in the problem. It can go 1 up or 2 up, 1 up, 2 right, or 2 up, 1 right.
Yes.
Okay. So at first I think so when I think about the solutions, because I can go from the answer the target so the horse is actually going right on top.
Mm-hmm.
Like inversely, when we try to think about how our target is going backwards, it's going like left and down.
Yes.
So okay. So I think one good idea is like starting from the target point. So for example, this is 4, 4. And what are there are two ways to reach 4, 4, right? So there's one. So this is being said on here. This 2, 3 can reach 4, 4, and 3, 2 can reach 4, 4. And yes. So but so we so given we had 2, 3, we can reach 4, 4. If, for example, if we have like n ways to reach 2, 3, then we have like n ways from 2, 3 to 4, 4. And we have like m from 3, 2, and we have m for 4, 4. So for our target, it actually sums up all the possibilities from both paths. And yeah, and one thing I would think is just going reversely and try to find try to sums up all the possibilities it has, and this sounds like a recursive because we are going from the target, and every time we have two cases, and the stopping case, the case we stop is so there's an x and there's an y, and when we reach to a point that has like smaller x than the beginning or smaller y than the starting point, then we stop because we can never reach the start point from a lower index, I think.
Okay. That sounds good. It's not. It's a straightforward solution. I think. I think if you are ready, you can start your coding.
Okay. Yeah, but this is like a brute force solution. But like, however, I think there are some like duplicate situations we have. Cause just imagine like we have other our start point is not 1 1. Our start point is from another index. And when we go back, these two cases actually meet at 1 1. So in my previous solution, we had to calculate 1 1 for more than one time. And I think that when we are going backwards, we can try to save the number of ways to get to a certain point in maybe in a map or something like that. So it's easy for us to so we don't have to like for this example we don't have to calculate 1 1 for more than once before that. Yeah, I think this is like this can reduce some cases, like pruning some cases. So if we already find 1 1 number of ways to get 1 1, we don't like recursively find the solution again. We just get from our saved number.
Okay.
Yeah. So can I start to write?
Yeah, sure.
Code? Okay. So public and what should I call this? So for this problem, we have like x0, y0, x1. I'm doing it in Java.
Yeah, I select the language for you.
Oh, okay.
Sure, no problem.
Okay. But I cannot like do tab. I cannot like indent over.
Okay, so so if you don't like the code block, you can just write in the plain text. Yes, and if you cannot do tab, you can do double space. It also works.
Oh, okay. Oh, I think okay, I will do like double that. Triple. Okay, so we also have to define our like recursive. So it's okay, so this is the place we're going to do our recursive calls. And oh wait, this actually let me think about what parameters should I pass in the DFS. Because we x1 and y1 just represents our current index, and x0 and y0 is what we are looking for. So there are actually two ways to going backwards. One is and so let me write the stopping case first. Okay, so when x1 is less than x0 or y1 is less than y0, this is when we cannot find our solution. Oh, I can do tab here. Oh, I cannot tab from start, but I can run. Okay, I will just do this. We just return 0 because there's like no way. if x0 equals to x1 and at y0 equals to y1, I guess we just return different one. Because we, wait, let me say, so this will be reached to the beginning. Okay. And then there are like two ways. Yeah, let me define. So there are two ways to go backwards. One is called negative and negative 2. Negative 1. 4. Equals x1 Okay, so here we get our new like the index we want to traverse back, and also we want the total to count to adds up number of ways for both cases. So okay, so here we need we actually need two for a data structure to record what
to cache the result that we already found out.
Yeah. To cache the result we already found, and this is like 2D array. I'm thinking about maybe using a map. Yeah. Let me just. So it will be. So the key for the map is our index. Value would be a number of ways to get to this index. What should I call it? I should call it ways. Near. Okay, a global variable. Okay, so here if we already have I'm thinking about should I use a map or like a 2D array?
Yeah. So what is the benefit or disadvantage of the both data structure?
Okay, so if I use a map, then every time I look for what's in the map, I have to create an array for new x and new y to see does it contain the key. And if I use 2D array, then I have to create a size equals to both so one dimension is x1 minus x0, and second dimension is y1 minus 1, 0. And yeah, so in this case we're not gonna reach all all the elements in 2D array, so there's some waste of space. But and meanwhile we have to actually at the same time we had to initialize our 2D arrays elements for -1, 2. That means we are never visited.
Okay.
And
okay, so you only compare the space complexity, but I'm more interested in the time complexity. So from the point of view of the time, so which one will be faster?
Which one will be faster of getting the result?
Yes.
Okay, so this is a hash map, so it take instant time, to find the key. Does it exist? And we don't for 2D array we had to create it first, and that's n times m, and then so I think using a map would be faster, because we don't really initialize it. We initialize in constant time, so we don't have to let me see. But I think creating a map, we have to initialize the elements all to -1, so we have to traverse the using a 2D array, so we have to traverse the 2D array once for all elements, so that would be n times m times n, I think.
Okay.
Yeah, so I think using a map is fine. I think it's save a lot of time here. So here is we have so if it contains key y. So if it contains this this key, that means we already visited. Total plus equals weights get should I call it new otherwise we just we just go try to find it. X0 0 so and then we return, and then we want to record this answer. Okay, so this is there, and then we don't let me see here. Yeah, we return the type.
Yes, that makes more sense.
And then here we try to call DFX 0 y0 1. I think we can just return it because it returns the final answer, I think. And
okay, so what is the time and space complexity of your solution.
Okay, so when we look back when we look at this example, it starts from the target. So our program runs start from the target, and it passes. Let me actually think about it, because we only like visit every state one time.
Mm-hmm.
So at most one time.
Mm-hmm.
So the number of states that we visit is our like time complexity. And yeah, I'm trying to think about what's the number of states that we visit in this. Okay, so like in this example, it actually like we move left once and we move right. We move like left one and down two. We also move like two down and y. Okay, so like for example, every let me think. Two down. I think would it be so would it be like all of maximum of x1 minus x0 and y1 minus y0? I think because we are
So what was the question?
You mean your question?
What's the question that is blocking you? What's the blocker?
So can I draw it on here? Because I'm trying to visualize what the structure of the tree looks like.
Yeah, sure.
And so this is for example, this is for, and it actually goes to like, so there are like two branches. Left, one is right, and there are like two branches, and this is like 2, 3. So 3, 2. And for each one of them, they are going like down. We also have like 2 branches. So like 2 branch. So this would be like it's 1, 1, and something else. And this would be also 1, 1. It will be something else. Okay, so So this is every time we split 2, 2.
Mm-hmm.
Yeah, but what I'm thinking about is because we did the pruning, we did save the result for some of the states. So for example, this is only saved once for this both 2 cases. So
Okay.
we only like miss one time.
So maybe you can think in the other way. So how many states that we have in this structure or in this graph?
Okay, in this graph.
Yeah, what is the maximum states that we will visit in this question, in this problem?
Okay, the maximum states.
Yeah.
Two plus So it's like maximum number of states. Oh, this I think it's kind of hard to analyze. Is it n squared? Yeah, I'm kind of I'm unsure about like how many states that we have like in total. Because if you start from the starting state and then you like move 2 until you like every time you reach out to 2 ways until the end,
Mm-hmm.
So it's also similar to this tree, the structure of the tree I draw here, but it's just it depends on the height of the tree. So how many levels it has, right?
Okay. So imagine that the Chinese horse is on a board. So I'm actually giving you a two position. One is at the left bottom corner.
Okay, I see your point. Okay, so if we think about like it on the board,
Mhm.
we can think about it going from like one corner to the diagonal corner. So
Mhm.
that would be like, okay, so total number of states would like definitely be x1 minus x0 times y1 minus y0.
Yes.
Okay, yeah, your explanation is much clearer to let me solve the problem. Yeah.
Yeah. So the reason that it's not like a tree. It started with like a tree, but it will converge at the end because you return 0 directly in some condition, right?
Yeah.
So it's not. It starts similar to a tree, but it not ends like a tree. That's the reason.
Okay, I see.
Okay. So can you write down the complexity space and as well as the time complexity? Yeah, in the doc.
Okay, time will be like the time. And is 0 and y1 minus y0. Space.
Mm-hmm.
Space will also be similar because we use the map to save all the states we visited.
Mm-hmm.
Yeah, valid states that we visited, and the maximum number of valid states was to this many.
Okay. Okay. So what is the range of the n and m that we can solve?
You
Like-
mean the
Like how big n and how big m that we can solve in this problem? And
okay.
yeah.
So our because I'm using like integer value to save x0, y0, and x1, y1.
Mm-hmm.
So we can go from very small little value like x0, and y0 can start from like negative.
Mm-hmm.
I'm sorry. Like integer mean value.
Mm-hmm.
And it can actually go to y1 because we are doing only addition every time. So integer x value. And number. Oh wait, and we also have to consider like we are using like map. We are like returning integer as well. So our like total number of ways also in integer, but it might guess like larger. It might guess larger than integer when there are a lot of ways. I think.
Okay. So if we consider the range of n and the range of m, where the n is the difference between x and m is the difference between y. So how big of n and m that we can solve in this problem? Because we don't have the infinity time and infinity space. So the time and space is both are limited.
Yeah.
So we definitely cannot solve the range between the minimum integer and the maximum integer.
Okay.
So do we have the concept that how big that we can solve, like the 10, 1,000, 1 million, 1 billion?
Okay. So are you asking the range of what value we can solve?
Of n and m.
N and m. So
Yeah.
what size of n and m we can actually solve?
Yeah.
Is that just okay?
Well, yeah, we are able to solve.
Are able to solve.
Mm-hmm.
Okay. So the like the board, the n times m is the size of the board.
Yes.
So it had to be definitely less than the maximum value of integer.
Mm-hmm. Okay.
And yeah, and size
I mean,
yeah,
imagine that the board is extremely big. For example, 1 billion. So I bet your solution may run into time limit exceed.
Mm-hmm, mm-hmm.
So it means that you cannot return the result in a short time, like a few seconds.
Yeah. 1 billion is like definitely like too large.
Yeah,
Like,
and if I give you the value like n m is only like 10, so you can return the result immediately.
yes.
So I mean, like between the extreme small and extreme big, how large? What is the range that we can resolve? Do you have any idea about that?
Okay, what's the range? I'm thinking about. I'm not sure. Like, how could I know the exact number? But I think like it should run pretty fast if n is like within like 1000 m is within 1000, I guess. But I'm not, to be honest, I'm not like super confident for my answer.
Okay.
But I think like 1000 would be a good limit for n.
Okay. Okay. Next question. So what is the edge cases for this problem?
Okay, so the edge cases.
Yeah, because I can see that you run directly into your DFS recursive solution, right? So you didn't handle any edge cases. So I bet that there will be some edge cases that you can maybe return the result directly, or you don't need to handle it. So this can also save the time that time consumed by this solution. So what is the edge cases of this problem?
Okay, so one edge case would be like, so the given input x, like our target.
So you can write down all the edge cases. I think that will be more clear.
You mean on the just on the
on the doc? Yeah.
Okay.
I suggest you writing as much as you can.
Okay. You want me to write in the code, or you want me to write just on the plain text?
You can write in the plain text.
Edge cases. Okay. So the first one would be x1 is less than x0, or y1 is less than y0.
Mm-hmm.
So this is when we can never find the answer.
Mm-hmm.
Okay, so yeah, let me also think about. Another edge case.
So actually, it's not have to be strict smaller. It can also just be equal, right? For the edge cases.
Wait. So if it's equals, there's exactly one way to reach that true. If like target points, target index is equal to the starting index, then we should return 1, right?
Yes.
Okay. Yeah. I think in line 15 to 17, and of my code, it actually like handled this situation. So
yeah,
I'm not sure. But I think it would be still good. Like if we can. Y1.
Okay.
Just return 1.
Okay. My point was that if x1 equal to x0, but the y1 and y0 is not equal.
Oh,
in this situation, you can also return 0. Yeah.
But is that true? Because I'm not like, for example, if x0 equals y0 and x1 is not necessarily had to equal to y1, right?
Yes.
So is that so wait, did you say like in this case we just return 0?
Yeah, I mean, for example, x0 and x1 all equal to 5, for example, and
okay. I see. You're saying like there's one index. Okay, I see your point.
Yeah, I mean the horse cannot move along with the x or x direction or y direction.
Yeah.
Okay.
So yeah, sure.
Okay. So
because like points only like move monotonically increasing.
Okay. Let me rephrase my question about the edge cases. So at the beginning of the problem, you asked me if the condition it guaranteed to have a ways, it guaranteed to be valid. So my question is that what condition of the input that can guarantee there is at least one way to jump from the start to the end?
Okay. So you mean like what conditions that guarantee we find an answer?
Yeah. So, for example, if I give you a condition like x0 is strict smaller than x1, and y0 is strict smaller than y1, so it may have a solution, but it's not guaranteed. So what condition?
So one scenario I would think about is when x1 minus x0 equals to y1 minus y0, and x1 minus x0 mod 3 equals to 0. So this is one case, because from our example, like from the example earlier, so 1 1 and 4 4 is actually like just we can get from 1 1 to 4 4 like in 2 steps. So if like this is equal, so then so the difference between two axes are equal, and both of them are like a multiply of 3, so we can get them in like so we can get to target in like 3 times 2. Yeah, that's true, I think.
So I can see that this is a sufficient condition, but it's not a necessary condition. Do you know the difference between sufficient condition and necessary condition?
Okay, yeah. Because there are some cases doesn't fit to this situation, but it's okay. So you want me to find the like necessary condition?
Yes. What is the sufficient and as well as necessary condition to guarantee that there will be one way?
Okay.
But I can see that you are looking in the right direction, because here you calculate the difference between x and check if it module 3 equals to 0.
Okay, so the necessary condition. Yeah. Let me think about it. I'm just looking at the example and try to find something.
So I'll give you a hint. So you can see that there's two ways of the horse. They can jump a relative right or relative top. And in either way, the horse will jump 3 units.
Yes.
Yeah. So the incremental difference is 3, and it will start from x0 y0 to x1 y1.
Yeah.
Yeah.
Oh, okay. So the increment is 3. Is that
The incremental difference in the direction of x and y, it will be 1, 2, or 2, 1. So the sum of the difference will be 3.
Oh, okay. Maybe we can. Okay, I see. Oh, I think I know. Because we so we I think we still look at the difference.
Mm-hmm.
And if so, this difference could be like so we can this difference could be like a multiple of 2 or 1, and the other x's. So we have like two different here.
Mm-hmm.
So so if this has if this like a mod I don't know, like how should I, it's just like an intuition. I still need to like thinking more deeper into this.
Yeah. Okay, that's fine. I can see that you are getting in the right direction, but you cannot transform the idea in your mind and to the mathematical equation right now. But that's fine. Okay.
Okay.
So
Yeah.
I have very last question about your resume. So you have the Bachelor of Science in ACMs and Data Science and Statistics. So what does the ACMS stands for?
SMS.
ACMS.
You mean like my major?
Yeah.
Okay, so it's applied and computational math science. It's applied and computational mathematical
okay.
science.
Okay.
So it's like a blend of a math, data science, and computer science, and also just it's more linked to like statistics. So I learned a lot like probability classes.
Okay, sure.
Yep.
Okay, so that's all for the algorithm problems. So do you have any question regarding this interview? To me or to the interview?
Or okay, I'm still like thinking about the last question you gave me, and so I think the difference, like, so every time it runs like 3 steps, and one is so it's not well, I don't know how should I formulate the question, but like it's going like, I think one should be like a multiple of 2 in one axis, right? Because it could like never.
Okay, we can talk about this question in the second part.
Okay.
So
Okay. Yeah.
Okay.
Yeah. So there's no like additional questions besides this one. Yeah.
Sure, no problem.
All right. Thank you.
Okay.